So last talk of the day, last scheduled talk of the day. Our presenter is an electronics engineer finishing his master's degree at the University of Melbourne, who is heavily involved in the Lua community and is going to tell us about application programming in Lua. Please make him welcome. Thanks.
Cool. I've been programming Lua since I was way back in probably year 10 in school, and since then I've done a lot of stuff. So about Lua, Lua is a dynamic scripting language. It's quite small and it fits 150k in memory compiled. You can skin it down to about 64k if you take out a few certain features, which means you can fit it way inside even your L1 cache, and also as well as embedded microcontrollers. So you can use it pretty much anywhere. It's quite fast on a lot of benchmarks. It tops other non-optimized scripting languages, so Python, Ruby. Sits quite faster than them, and with LuaJIT, which is a JIT compiler, it pretty much goes on level with C, compiled C in speed. So the regular complaints about scripting languages that they're not fast enough is completely unapplicable. I think the C API is quite good at stack-based, which some people don't like, but that's your own thing. And it's quite well known in the game industry, especially for being highly embeddable. A lot of games will use it. WoW is half written in it. I can't think of other games, but like Adobe Lightroom is pretty much written in it, as well as anything on your phones. As you like Angry Birds, all the levels will be scripted in Lua. It's everywhere. But it's very rare. Oh, that's not the right thing. It's very easily used to actually write applications itself. It's only used for embedding. Commonly cited reasons would be that there's no modules to use. Lua itself doesn't come with many batteries. So if you want to use threading, sound, video, even a lot of things that you'd expect to be that are in POSIX you can't use. You can't iterate over a directory without these libraries. And since probably about 5 or 6 years ago, the libraries were hard to find and hard to use, but since then that's been like quite cleared up. There's a thing called LuaRocks, which is very equivalent to Ruby Gems or Python eggs, which makes it very easy for users to install. The other thing people complain about is that there's no one library to do each task. If you want to, say, have an array, there's not only one way to do an array, which gets newbies very confused. One of the few applications written in Prosody and out in the wild is Prosody, which is an XMPP server, which is, quite well known, I guess. And this is just a small side note. I personally don't know what to think of how to fit LuaRocks and these Ruby Gems into your distro. They don't mesh well with the package manager. That's something that I'd like to talk to someone about, but yes. Cool, there's some very cool benefits about working in Lua. There's only one native data structure called the table, which is an associative array from anything to anything, and you can mix types. So if you want a normal array, just use integers as keys. You want a set, you just use whatever your set values are and all set them to true or something. Structured dictionaries, just use a string key. It's all quite optimized, and you sort of can't go wrong. You just write whatever comes to your head and it generally works. It's also got coroutines built into the language, which is essentially context swapping, which is very useful with dealing with callback-based APIs. I know for an example would be in Node.js, you end up writing every function with a callback. So if you swap this back to being coroutine-based, when your callback just resumes your function wherever it left, which means you can write everything in a very linear fashion, which I like. The other biggest thing lately is LuaJIT FFI, which allows you to call native C functions without anything besides a declaration and a shared object, and also lets you use native data types and structures, which obviously you get the extra speed instead of using the double, which is only one number the single number format in Lua. You can use ints and actual structs instead of tables and stuff. And lately I've sort of stopped using the traditional C API for Lua and written everything with this foreign function interface. This thing is really annoying. A few graphs with Lua. All strings are interned, so it's very hard to have an actual buffer. as in if you're just getting a buffer from one API and want to give it to another one, Lua interns it. Obviously, the FFI fixes that. Otherwise, there's no bit library built in, which means you have no bitwise operations, which can get very bad when other APIs expect you to be masking things or grabbing things out of bit masks. In Lua 5.2, they did bring out the bit library, which has fixed that, and LuaJIT has come with one built in for a long time. Otherwise, there's a few. I don't know who here actually just programmed in Lua before. Anyone? Cool. Just a brief note. There's things called meta methods, which is when something traditionally wouldn't work with the type, is then you try and concatenate two numbers together. Numbers are a bad example. Concatenate two tables together that essentially has no meaning, so you can provide a backup operator. Same with adding. It's how you do, I suppose, objects. If you want to add two tables together, you provide a backup because there's no default plus method. But there's a problem because you can't override things sometimes, which means when you want to encapsulate an object within another object or a proxy object or something, you can't defer everything through, which is sort of annoying. Why doesn't down work? Okay, Lomp is my personal project. It's a Lua Open Media Player. It's essentially a client-server media manager and player, very similar to MPD or XMMS2 in architecture, although I've got quite a few personal preferences, such as use a queue to put songs on instead of a playlist, and then playlist puts in the queue, then you media manager, manage a playlist, etc. And in creating this project, I had to pretty much sort out what to do with these modules. And as I went through, I needed audio tag library, an event framework, audio decoding, audio output, some sort of database to keep all the songs and their metadata in, as well as a way to make clients that people would want to use. Obviously, it's not finished, and it's still got quite a lot left, which I haven't been able to do much lately because of work. So, library choices. For a tagging library, I went through every option there is, libtag, libid3, everything, but there's no sort of good one catch-all tagging library which does every format that I wanted. So that was MP3, FLAC, WAVPAC, OGG. And there's also features that they all miss, such as you can't have multiple values for each key, for example. So FLAC allows that, RD3 doesn't for some fields. It was a complete mess. One of the few libraries I would actually recommend for it is called Mutagen, which is part of the Quadlibet project. It's the only thing I've ever found that can seem to manage tags correctly. Anyway, I decided to pretty much write my own tagging library, which is rather complete. I just haven't really packaged it. Otherwise, for audio decoding, I started off with that as a sort of last thing, which is a bad idea. So I wanted to have a callback list. A callback for each frame of audio is actually quite a bit of overhead. I didn't want it to use threading, so the G-stream was out. I wanted it small, knocked out sort of FFmpeg and stuff. And I was trying to look into libVLC and other such things that were quite complex for what I needed to do. So I ended up binding every library and every codec manually, which was not as hard as it sounds with the FFI. I could essentially just make a small wrapper around each library. I'll show you that in a sec. Audio output, I used OpenAL. It's one of the few cross-platform sort of audio output things that you don't need to touch configuration for. As in you just select the sound card and the sound comes out. It works with ELSA, why can I not think? Pulse Audio, works on Windows. It even works on embedded devices if they've got the right thing set up. It's probably the best thing out there. And event framework, responding to sort of as a client-server media player, you need to respond to select or epoll, etc. libev was the best way to abstract all that. And data management, I did it all with a Lua table and persisted it to a file. It's quite a dynamic data structure. So to use LuaJIT, the FFI, you need to pre-process your header files. As in, so you get the original library, you pre-process the header files, and it reads all the declarations and types, and you can just use it. So to do this, you have to use GCC as a preprocessor, which is a lot harder than you might initially think. Obviously, you start with just chucking in -e for preprocessor only, and I'll actually try and show this. So I have a bigger resolution when I was practicing this. Okay, so just say we want to send sound file, was my example. Start sending it through your CE, and you have a crapload of line markers, which is being cut off. Okay, so you have these things which are not recognized. Next step was to chuck in P, whoops, which extracts all them, which actually is quite good for feeding in to get all your function definitions. After this point, so obviously to automate it, you have to add include directories. And for most C libraries, that's what you need for function definitions. But when a C API expects you to use a preprocessor, so when a C API expects you to have a preprocessor and be writing in C, can get quite more complicated. And a lot of, for example, headers will then themselves include systype.h. And then if you then preprocess two different files, they both get all of the systype.h headers, and then you have redefinition errors, which is very annoying because you write one library using the FFI and it works great by itself. You write another one, it works great by itself. Put the two together, you get all sorts of redefined errors. Really bad. You sort of learning out of this, I sort of concluded a few good things about good C programming. Defines and macros should essentially not be seen by a C library user. All defines can almost reasonably be used as enums instead, and I don't see many reasons not to. For example, seek set cur end in your standard ANSI-C header files. They're impossible to get out of the GCC preprocessor. You have to actually go in and grab them with EPDM. Only way to get those out, which is very annoying. And in fact, actually, I had to pass all these with a regular expression to try and extract these common things because they're different per system. On program startup, or first program startup, I generally try and create a database of all these original defines and macros. Obviously, macros can't call it all. I'm from a different language. I don't understand C macros. So where you can, just use a function inline if you have to. Except for obviously things that are only applicable to C, such as macros, where you want to have a nice iterator for people to use, or pre-input a for loop, say you're a linked list or something. I don't know. Been through that. So a few tricks with the FFI, you can pretend that your type is a different type. Say you get a void back from a library. So Webpack was an example. You can just make it into an opaque type, and the FFI doesn't care what it's passing around, and it makes it so you can attach type information, because otherwise it gets mapped to void, and you can't attach type information to void. And to avoid the whole redefinition errors, every time you run GCC DM, you've got to feed it back into itself on top of the next input file, which can get quite annoying. But it's good because you can also, once you made these forever for each shared object or library version, you can then distribute these with your executable, or for Windows, or a few annoyances in the differences between command line for actually generating these, because I'll call out to GCC with execute. So echo in Windows doesn't support new line. You can't press an enter in the middle of it, so every line in the text file you have to put to a different echo command to pipe to whatever your thing is. The greater than character has to be escaped with a caret. Otherwise it does redirection. Redirection to a file. For standard error, it's 2 greater than as opposed to and 2 greater than and null versus dev null. Just a few differences that took me a while to actually figure out. File formats. So writing a tagging library had to deal with a lot of different file formats, and I think that I would know what to do myself if I ever had to write one. Prepending to a file is very hard. A lot of libraries provide buffer space at the start, or a bit of padding. Often this padding isn't enough, which means that you have to rewrite the whole file, especially if it's something like a FLAC file, which can be, say, 400 meg, and you've got a bit of metadata at the start of the file. If someone wants to add, say, a picture, or a picture of the album art at the start. You have to read the whole, you have 400 meg, and you have to read into the next thing. Now, I want this to work on a memory-constrained device. I am not happy. Otherwise, in NCC, there is no truncate or f-truncate. This amazed me. I don't know how it was sort of overseen. So to actually be completely cross-platform, you have to make a new file, copy everything across, delete the old file, copy permissions, which isn't in ANSI, but yeah, and then rename the new file, because that's the only operations you have in ANSI. Also missing a sub-second timing and sleep, which I ended up using the select call for, because they're all cross-platform. It's the only nice cross-platform sleep around. Endianness. A lot of the times flags will swap in bit endianness inside a single file format. So you'll be reading something about how many channels an audio file has, and it will be inside a little endian byte with a big endian, like 2 bits in the middle that the number of channels. But then again, later you'll have the sample rate, which is inside of the opposite endian this byte with an opposite endian this bit. So to actually extract these things is stupid. And just as FLAC is a relatively new format, it actually uses both endiannesses as well. So it uses one for its header, and then because it uses Vorbis tags are length prefix strings, and the length is a little endian, while the FLAC has all its details in big endian format. It's a complete mess. And network protocols. Because I was very similar to MPD and XMF2 in architecture, or at least at a superficial level, I tried to sort of put a compatibility layer in so that their clients, which not look all pretty, and you've already got them on command line, you've already got tray icons and stuff for them, you could use them with my player. It's not as easy as I hoped. For XMS2, their Y protocol is completely undocumented, and their C library to talk with it is also undocumented and changes every couple of months, or at least it did back 4 or 5 years ago, which meant it was completely unworkable. While MPD was, their original format was quite well documented, but since then they've implemented all sort of extensions which weren't mutually usable, I guess. So if you use one feature, you couldn't use the other feature, and they'd change as they go up versions, but I wanted to support all of them, which I couldn't. And otherwise, there's quite a few protocols that serialize native data structures. So between computers, they don't make any sense. They'll just just like save an int or something into a struct and send it over. They assume it's going to be on the same computer. It might not be. An int is now 64-bit instead. You can't read it, as well as it's just annoying as hell. And empris, which is a massive thing. If you in your regular distribution, all like your multimedia keys on your keyboard and anything up on your tray to do play, pause, etc., they all use a dbus thing called empris, which is okay for basic things. It's actually quite a long, I suppose, definition. It also supports how you have to send a playlist through for it to be displayed, about what metadata fields you have to have, and these are completely incompatible with what I had envisioned. So that sort of compatibility was hard to get, and that's pretty much it. I wanted to. How much time do I have?
Not much.
Cool. All right. Questions then.
No questions? Okay, maybe you can do your demo. Oh, okay, sure. Hang on, there's a question up here.
You were saying that the compiled size of a Lua program is typically under 150 kilobytes.
Well, the Lua interpreter itself is 150K for the reference interpreter.
Ah, right, the reference interpreter, I see. I was going to ask how large the interpreter wound up being.
Yeah,
cool.
So the interpreter is 150K, and then you just have your text files, which, well, however long they are.
You've just knocked your cable out. That's the problem.
No, I didn't. It's on the wrong mode.
Yeah.
That one. Yes. No, that's turned off my laptop. That one. No. That one. Yes.
Got there eventually.
So do a quick demo of how you might do a libsound file. I'm hoping that's a relatively an API that you might all know, or at least you know the vague bits of it. I don't know. So this is the libsound file documentation. These are the functions you have. It's pretty much, if you don't know, it's a library for reading every different type of endiness of like WAV file and stuff and converting them to whatever you want. So usually to PCM 16-bit data. So as a demo of the Lua FFI, I would, okay, so for those who know Lua, you don't need that. FFI is that. I'm loading this file. So the output of this command, I'm just saving to sound file defs.h. Except that I forgot the minus. Which you can just see is that pretty much. Load that straight in to Lua, which is just open the file and read it. Give it to FRCDefs, and now I can immediately, and then load the DLL, or sorry, the shared object. So go on and using these docs, you can, I'll just do, because it's very quick, I can probably just do a version command. I'm assuming it's got one. Command. Okay, so first problem here is obviously that we don't actually know what sfc get lib version is. It's going to be in the header file somewhere. So at this stage, just to be quick, I'm going to just search for it. No? Oh, sorry. Actually, just remember that this library is good, and that's an enum, so we're actually sweet. Cool. So libsound file .sf command. You need a sound file object, or it can be null, I'm assuming. Sorry, I'm just checking what it takes. It takes 0, it takes a buffer and the size of buffer. So here we go. And what we need is a pointer to a buffer, so that's actually that. And what does it return? An int. Print it. And then print fi.string of buff. Hopefully that will work. I haven't tried this, so cool. Wonderful. So instead of actually writing you can afford if you want. Instead of actually writing a full binding to the library, you can immediately call it from Lua without any, I suppose, extra logic. Which means you can go straight off the docs instead of messing with the stack, which I know people didn't like. Yeah, cool. That's pretty much it, I guess.
Awesome. Okay, well, thanks for the talk.